Welcome to the third part for Module 6. What we're going to do now is to build on what we've done, but we're going to do, rather than having a uniform height of our folds or of our pleats, we're going to introduce the graph mapper. And this is something that we haven't used yet. It's a nice introduction to this because it allows us to control the overall, or allows us to set graphically change a number of variables. So this is where we left off. I'm going to copy my curves. Actually, you know what? I don't like how that looks. I'm going to copy, delete that. I'm going to copy this one over and then copy it again too. The curve that I made the second time around didn't look as nice. So we'll feed it to this curve. We have that. So that's looking pretty good. We're going to have a nice progression as we move across. So why don't I copy these two? This will set us up to add one more level of sophistication to our sequence as we start thinking about this. And I'll do the same thing. We'll copy this whole guy over to the right. And let's name it. Click on the group, right click, folded, non-uniform. So before we do that, I just want to introduce the graph mapper. Maybe I'll do this. I guess I can do this right underneath. So the graph mapper looks like this. Once you first use it, it looks kind of ridiculous. It's just this incredible black or gray square. I promise it's worth using. So let's right click on it and we can see that there are graph types that are preloaded. I'm going to use Bezier. We've talked about what Bezier curves are. We kind of understand how they work. So let me just do a short introduction to the graph mapper, and we'll use it in a couple of different ways, but I'm going to make a slider of 1. I'll use the real value, and I'll plug that in. As I move this from 0 to 1, we see that the graph mapper goes from 0 to 1 and from 0 to 1. I wish that these could be sliders or inputs, but you can only type them in. And so we'll get to that in a second, because really what I want is from 0 to L2, but we're going to have to kind of work a different way and do a conversion. But for now, as we move left to right across here, let me add a panel so you can see what happens. And so because this line is linear, diagonally across, whatever the number is here is the number that's coming out, right? Because as it moves, we just plot between these two. But as we start to change this, watch what happens. The value on the right, as it comes out, the Y value, right, as we're moving this, we're basically moving left to right from 0 to 1 in the x-axis. What's coming out is the y-axis of the black line. We can see that they increase. So it's easy enough to see with a slider. It's even better to see with a range. So let's give it, instead of one value, let's give it a range of values. So the default is what, 0 to 1 with 10 steps. And so now we can see 0 to 10, and we can see the way that these change and the way that they increase slowly, increase to a greater speed, and then increase to 1 at the end. So that's nice. The other thing that's worth noting, though, is that normally when we say something has a certain number of divisions and we give it 10, right? That this input over here is 10 for steps. We actually have 11. So this is something that's we're going to have to correct in a second, because with range, when we give it 10, it actually gives us 11. And so we're just going to have to subtract 1 from one of our numbers above as that happens. Okay, so let's look at what happens when we use the graph mapper to deal with these guys so that they're no longer a uniform in terms of heights. The total still needs to equal the L2 dimension at the end. So I don't know if we've done this yet. Let's set our curve to be our straight line on the top, so we can see this a little bit better as we use the graph mapper. So coming into this, remember I told you that we wanted to subtract 1. So let's look at our number of divisions. Let's go back to 5, to where we started. If we plug 5 into our range, or into our steps here, we're actually going to get 6. So let's make sure to subtract 1. So we'll use subtraction. We'll plug this into A. We'll do a panel. Again, I like using the panels for these really simple inputs because we can see them visually. Set that to 1. And then we'll feed this into our steps. So now we're going from 0 to 1 across 5 steps, right? Which is 0 to 4. So that looks good for us. That's what we need. Now, here's one issue, not issue, but something that we'll just work through kind of simply, is that going from 0 to 1 doesn't really give us a kind of rational number at the end. What it gives us is something, right? The addition of these is something greater than that. And what we need to do is understand that and map that back to our L2 dimension. So there's another really useful command called mass addition and mass multiplication. Mass addition basically gives us the sum of all of these elements. So I can plug this in here. The result is going to be one number, which is the summation of all of these numbers above it. And the reason why we need that is that it's almost, the example that I use is that like doing a kind of simple conversion, and maybe even Fahrenheit to Celsius or Celsius to Fahrenheit, there's 2 different scales. And what we have to do is map one set of units to another set of units across that. And that's basically what we're doing here, is that we're going to take a series of inputs and we're going to look at the addition, but the total is 2.2 and it's going to change all the time. And so what I want to do is divide this by 1 and you'll see what happens. And so let's do a division. And we'll take that value. Is that right? No, we're going to take 1 and divide it by the result. So we'll do a panel again. Just going to plug 1 into there. Set that. And let's see what we get out from that. So that's 0.44. And what we'll do is we'll multiply the outputs from here times that value, and these should start to kind of balance out. And I'll prove it to you, maybe better than I can tell you. So let's multiply our 5 output values by this value. And it's going to take 2 steps to prove it to you, because those are weird numbers. But watch what happens if I, again, do the mass addition. These should now equal 1. So the result of that multiplication, the mass addition, in the end equals 1. And what's good about that is that if I know that that's 1, I know that this is kind of balancing out. And 1 can map easily to our L2 dimension, and then we can just go from there. So let's take those set of values, which come from here, and let's multiply those times our L2 value. And really what we're doing is getting back to the point of recalculating C based on the graph mapping. And so we're going to end up swapping out this C value for the values that come from down here. So maybe I'll make a little bit of room. And so where were we? This was just a check on the end that it equaled 1. So we're going to take the output from this. We're going to do another multiplication. And we're going to multiply these times L2. And we get that. And so the last step is just to know that the L2 is the total length of the folding. What we just did is we divided that by 5, right? But we should have divided it by 10. The reason why we didn't do it by 10 down here at the bottom is that we want to basically take that length and then split it in half. And so as it plays out here. So basically we'll just do one more multiplication and we'll multiply these values times 0.5, or we could divide by 2 as well. Maybe we'll do that. Divide or division. We'll divide these, A, by the panel. We'll divide them by 2. And then these will be our new C value. You can slide this over, plug that into C, and look what happened. These values started to change. And let's see where we are. We'll zoom in for a second on our Bezier curves, and we'll just get them to a point where we can play with our curve. And we can control our heights. Really what I wanted to be able to do is say, okay, let's start, rather than just having it be a uniform thing, maybe one side is a little more folded than the other side. And so we can use the Bezier curves to just control that a little bit. Right? Or maybe it's in the middle, we get more of a peak, or it's to one side, we get more of a peak. But it's really nice to be able to control these, and you can play with both the edges, right? We want to make sure, watch what happens. We have our L2 check up here as well. Our L2 is set to 326, and amazingly, our L2 check, which is coming from the length all the way at the end from our polyline over here, those two things are matching up. And so it's really in those few steps down here at the bottom where we were kind of going through first controlling our range. We had to take one away, using these values based on the number of divisions. Let's change that as well. We started with 5. Let's increase it. Now we've got 21. We can see we've got 21 values that are coming out of the graph mapper. We had to figure out their total addition, divide 1 by them, use that to multiply it through, and then just check that those came out to be equal to 1 or 100% of something. And then we can use that tied back to our number of divisions. So all of that's working. And in the end, our L2, 326, which we can increase or decrease. Just want to make sure it's long enough so that nothing goes totally flat. Right, and we can see as we push one part down, another part goes up, because what's driving it is the total L2 length. So I hope this makes sense for you guys. I know it's maybe a little bit more math than you wanted to deal with, but what's nice, or hopefully what you get a sense for, is the level of control that we now have as it relates to that. Oh, and of course we have to try it on our curve down below. Let's reset our group. Oh, because we lost our first grouping, that's fine. We would call this folded non-uniform. So we have that. Let's now change our curve, our input, to our curve down below. And that's working, but because of this line is longer, right? This is 174, this is 308. We can increase our L2. And we can see the same things happening. We get the kind of spikiest part over here that we're controlling with the graph mapper. We could flip that around. Can reduce the height on this side. Just, again, want to get it so there's enough length so that everything's popping up just a little bit. But you get a graphic representation of what's happening with your numbers. Same thing, we could change our curve and these things would update as well. But it's nice to be able to zoom out and see just from this kind of step-by-step approach, right? Can we get it to be, can we find our normals? Yes. Once we found our normals, can we do this in a uniform way? Yes. Once we have it in a uniform way, let's look at something with a non-uniform way. So over the course of these couple of short tutorials, which I know are not so short today, but they're building on different things, you started to understand normals for a curve. We introduced the length and really using the length component as a way to check a couple of things. You get a little bit more exposure to the expression tool and using a formula, a refresher in Pythagorean theorem, graph mapping, as well as mass addition, when you need to look at taking a whole bunch of items in a list and starting to group them together. So let me do one zoom out here. And I can even pull this over more, so you can start to get a sense of the overall thing that we worked on. And again, being able to use everything is based on our overall length of our pleated or folded surface. So we can change our geometry, we can change the number of divisions, and we can change the overall length. And then with the last step, we have a non-uniform way of being able to do that with the graph mapper. So I hope this works. This should be crisp enough that you should be able to see everything that's here. And this sets us up well for the last part of the tutorial or of the assignment this week, is that we're going to make controlled lofted surfaces based on the control that we've built from adding the pleated, let's say, section to each of these, and then we'll go from there. So let me know if you have any questions about this, and we'll move on to the next part.